Good morning. We are going to do new notes. Even though I'm not here, we're going to do notes together on this video. So pause the video and find 3-2 notes, rational numbers. Okay, so what is a rational number? A rational number is pretty much any number that you can think of, all of the normal type numbers. So let's do some examples. We could have a rational number could be a decimal, 0.5. A rational number could be a fraction, 1/2. A rational number could be a -7. A rational number could be a square root, like a square root of 16, because that answer is 4. A rational number could be 8. A rational number could be 0.2 repeating. Pretty much anything you can think of is a rational number. So you're asking yourself, okay, well then what's not rational? If it's not rational, that makes it irrational. Irrational. There's not very many numbers that are irrational. The most common one that comes to mind is pi. Remember, pi was the 3.14, and we use it when we're finding circles. That one is irrational. And then the other category of irrational numbers are square roots of decimals. So the square root of 16 is pretty. 4 times 4 is 16. But the square root of 17 is not pretty. It's a decimal. So what makes something irrational versus rational? These are decimals that go on forever and ever with no pattern. This decimal stopped. This would be a decimal that stops. This is -7/1, or it's just number 7. So it doesn't go on forever and ever. This is the number 4. It doesn't go on forever and ever. 8 is just 8. 0.2 repeating is the same as 2/9. So it could have been written as a fraction, and we've already said fractions were fine. So repeating decimals are good. Non-repeating decimals are good. Negative numbers are good. Positive negative numbers are good. Fractions are good. Pretty square roots are good. So irrational, they're going to be repeating. No, they're not going to be repeating. They're going to go on forever. They're decimals that go on forever with no pattern. They go on forever with no pattern. On and on and on and on and on and on and on. They never end, but there's also no pattern. Okay? So if something is rational, it's pretty much every number you can think of. All the different types, the decimals, the fractions, the negative numbers, the positive numbers, the repeating numbers, the pretty square roots. All of those are rational. Now, let's go to the next category, which is rational and integer. Rational and integer would cut out the 0.5, the 1/2, the 0.2. Okay, none of those are considered integers. Integers are negative or positive whole numbers. Negative or positive whole numbers. You can't have any decimals, you can't have any fractions. Negative or positive whole numbers. We could also include this guy down here, the square root of 16, because he's really a positive 4. Okay, so rational is a huge category of pretty much everything. Integer is a little more specific. We've eliminated some of these, so it's a little more specific. Now let's get even more specific. Whole numbers can only be positives. 0, 1, 2, 3, 4. Square root of 16, because he's really a 4. Natural numbers is even more specific. It's only going to be 1, 2, 3. This 0 is not a natural number. So natural and whole is pretty much the same. It's just that whole numbers can also have 0. Natural numbers are positive whole numbers that start at 1, positive whole numbers that start at 0, positive or negative whole numbers, decimals, fractions, negative numbers, positive numbers, square roots that are pretty, decimals that repeat. So this category is huge. We got a little more specific, a little more specific, a little more specific. Okay, so your homework is going to give you a number, and the directions are going to say name all sets to which each number belongs. So our options are rational, rational integer, rational integer whole, rational integer whole natural. Those are basically your 4 options. You're going to say, is it in this category only rational? Is it a rational and an integer? Is it a rational integer and a whole number? Is it a rational integer, whole number, and a natural number? Okay, so example 1. Example 1 is going to be 13. Name all sets to which it belongs. All right, so 13 is going to be rational. It's a positive or negative whole number, so that makes it an integer. It's a whole number, and it's 1, 2, 3, 4, 5. It keeps going, so it's natural. That one would be all 4. Okay, example 2, let's do negative 9. Negative 9. All sets to which that one belongs, it's rational and integer. It's not a whole number because whole numbers can only be positive. It's not a natural number because natural numbers can only be positive, excluding 0. So negative 9 gets 2 labels, rational integer. Example 3, square root of 20. Is that going to be a square root like 16, or is that going to be a square root like 17? That one's going to be a square root like 17, so that one is called irrational. Okay, next example, example 4. Let's do negative 2/3. The answer is only rational. Negative 2/3 would be this category up here. It can't be this category because those can't have fractions. And if it's not in this category, there's no point in going down further. It's only this category. Okay, the next part of your homework is going to say write each decimal as a fraction in simplest form. We have 2 options. Hopefully what I'm about to say is something you remember me saying before. Hopefully it's old news. Okay, so number 1, you could say it correctly. You could say the number correctly, like 2/10, 42 hundredths, 173 thousandths, 1 4/10, right? If you can say it correctly, you should be able to write it correctly. The other option is to count. Count the digits, and that's going to equal the number of zeros. Count the digits, and that's going to equal the number of zeros. So we might put it over 10, we might put it over 100, we might put it over 1,000. If it has 1 digit, it goes over something with 1 0. If it has 2 digits, it's going to go over 2 zeros. If it has 3 digits, it's going to go over 1,000 because 1,000 has 3 zeros. Okay, so let's write our first example. Example 5 is going to be this number right here. If I don't say it correctly, 0.07, right? I mean, that's not really correct. We usually say it because it's just fast, 0.07. But let's see if we can say it correctly. 7 Is it 7/10 or 7/100 or 7/1000? 7/100. 7/100. Option 2 is we could count 1, 2. There are two numbers, two digits past the dot. So it's going to go over 100 because 100 has two zeros. Now we're supposed to be simplifying it, but 7 is odd, so I don't think we can go any further than that. If the book makes it negative, then you just say negative. The negative doesn't do anything except stay there in the answer. All right, let's try example 6. Are you going to try saying it correctly, or are you going to try counting the digits? 15 has two digits, so it's going to go over 100 because 100 has two zeros. 15/100. Now don't forget, I have to simplify it. So what goes into both 15 and 100? Well, what popped in my head was 5. So I need to simplify the numerator, divide it by 5, divide the denominator by 5. 15 divided by 5 is 3. 100 divided by 5 is 20. Final answer, 3/20. All right, let's try example 7. Say it correctly, or count the digits past the decimal, and that's going to be the number of zeros in the denominator. 4 and 3/10. 4 and 3/10. One digit, 1 0. One digit, this digit doesn't count. We're not counting, he's not part of our count. Only this one is part of our count. One digit, 1 0. 4 and 3/10. I can't simplify it, so I'm done. Okay, try this one. $128 is going to go over 1,000 because I have 3 digits, so I need 3 zeros. 128 over 1,000. Now I need to simplify it. I could simplify by 2. They're both even, and when in doubt, just divide by 2. But I know 4 will go in to both of them, and possibly something larger, but I think I'll just start with 4. It's what popped in my head. I'm proud of myself, I'm not doing a 2. So let's do divide by 4. Divide by 4. I end up with 32 in the numerator. 250 in the denominator. Well, they're both even, so I obviously did not pick the largest one. Let's go 2 again. 16 and 125. 16 is even, but 125 is not. 5 can go into this one, but 5 can't go into that one, so I'm feeling like we're done. 16 over 125. Okay, let's look at these notes. Oh my gosh, are you kidding me? Okay, Okay, here we go. We're gonna take repeating fractions. Okay, here we go. Are you ready? There's 4 steps. We're gonna take 4 steps. Okay, just trust the process. Here we go. I know. I'm just anticipating already. Your mind is going to be blown. Okay, here we go. Step one. You're going to write x equals whatever the question is. So in this case, our question is 4 at 89, 4.89 with the 89 over the bar. Okay, step two. I want to multiply the left side and the right side by something, the same something. Whatever I multiply over here, I want to multiply over here. And I want, you know what I think I'm going to do? I think I'm going to erase this bar. And let's write 89 a couple more times. 89, 89, 89. And we'll even go dot, 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 dot. So we know that we're not just like stopping it. Okay, so this number has 2 digits that repeat. 2 digits that repeat. So now I'm going to I need to make this decimal move behind the first repeating chunk. Like if I move the decimal here, I didn't clear the chunk. It's a 2-digit chunk. So I'm going to have to hop it 2 places to get past the first chunk. Okay, so that means 2 hops is 100. So I have to multiply both sides by 100. I'm not always going to multiply both sides by 100. Maybe I only have to multiply both sides by 10. Like if it's just a 1-digit thing. But this is a 2-digit repeating thing, so I have to go by 2 zeros. Okay, then I'm going to subtract, and then I'm going to sing. Sing means the same as solve. Okay, so step 1 is you write x equals the question. Step 2, you have to multiply both sides by something. Step 3, you're going to subtract, and step 4, you're going to sing. So it says on the back, so we're going to actually try 4.89. We're going to we wrote the steps to ourselves, but we're actually going to go through those steps. So flip your paper to the back. Here we go. So I have x equals 4.898989. Then I'm going to multiply both sides by 100. And I'm going to say 100x equals 489.898989. Okay, let that sink in for just a second. I wrote the question. X equals the question. Then I needed this decimal to go back here. So that's 2 hops. So I have to also hop this guy, which remember he really is a 1. We don't see the 1, but he really is a 1. So we hop the 1 2 hops to make him 100. We put it on top. That's important. We're going to put it on top. And now we're going to subtract. Now, 89 went on forever and ever. But do you agree that these 8s would become a 0? And these 9s would become a 0. And these 8s would be a 0. And these 9s would be a 0. And I'm going to have 0 forever and ever and ever. And now I have 9 minus 4. And then an 8 and then a 4. Oh, look at that. It's not repeating anymore. It's just the number 485. We got rid of the repeating forever and ever and ever junk. Okay, now on this side, if I have 100 apples and I take away an apple, I have 99 apples. So 99x equals 485. We said that step 4 was to sing. So I bet you can look at this and figure out our song. Divide by 99, divide by 99, cross out what's my answer. Okay, so we don't want to get a calculator out because remember the whole point of this is we're trying to make it a mixed number. Like what mixed number would this decimal have been? If I use a calculator, it's just going to tell me 4.89 repeating. Okay, so 485 falls in the house. I know it's going to be 4 and something. 9 times 99. 4 times 99. 36, carry the 3. 36, 37, 38, 39. We're going to write 396. We're going to subtract. And I got 89. The whole point of this is a mixed number, so I write 4 and 89/99. That, my friends, is the fraction, the mixed number, that is this repeating decimal. We did it. 4 and 89/99. Okay, let's try negative 5.7 repeating. Negative 5.7 repeating. Okay, step 1 said let x equal the question. I need to move the decimal behind the repeating chunk. This is only a 1-digit repeating chunk. So I'm going to say 57.7777. That's 1 hop. So that's the same as multiplying by 10. Step 3 said subtract. 10 apples minus 1 apple is 9 apples. 57 minus 5 is 52. These all go away. I don't have a decimal anymore. Now I'm ready to sing. Divide by 9, divide by 9. Cross out what's my answer. 9 goes into 52 5 times. $52 minus 45 is 7. 5 and 7/9. Oh, but wait, wasn't it negative? It was negative. Negative 5 and 7/9. So I forgot about the negative sign all the way until the very end. I don't need the negative sign here. I don't need the negative sign here. I'm just going to remember to put it here when I'm finished. Okay. 12.01. If you want to pause the video and try this one by yourself, or you want to do it with me, either one is fine. So you can pause the video and try it, or here we go. Let x equal the question. I need to move it 2 hops, so this is going to be a 100, not a 10. 1201.010101. I'm going to subtract 99x. These all go away. And I borrow, make this a 1, make this a 9, make this an 11. And I got 1,189. Now I'm ready to sing. Divide by 99, divide by 99, cross out what's my answer. Now remember, we know that it's 12 point something. So this is going to go in once. This is going to go in twice. There's our 12. 99 times 2. Oh, I did something wrong. Oh, this is 279. 279. No. No, that's not right. What did I do wrong? This is a 0. Oh, 199. Okay. Let me erase that. So I got 1, 9. Then I bring this guy down. Okay, so it's going to go in 2 times, which is 198. So my final answer is 12 and 199th. Was it negative? It was not, so I am finished. Okay, we have one last question, and this one's weird. Because do you see the bar is only over the 4? The bar is only over the 4. Okay, so step 1 is to say let x equal 0.144444. This one is weird. I don't think we can do this because what if I do 10x? Then I get 1.44444. And that's not good because these go away, these go away, these go away, these go away. But look, this one doesn't go away. Oh, okay, we're going to have a new strategy. We're going to have to say 10x is 1.44444. Then we're going to have to say 100x equals 14.444. Now, I don't know if you'd ever thought of that, but that's sure what we're going to have to do because we need all the repeating junk here. So step one didn't work for us. We have to go to this new plan, this new step 1. So we're going to have to multiply both sides by 10 and then multiply both sides by 100. So now the 4's, all the repeating junk goes away and I'm left with 13. Because the whole point of this is I need a whole number. Then if I have 100 apples minus 10 apples, that makes 90 apples. We are ready to sing. Divide by 90, divide by 90. Cross out what's my answer. And I don't think 13 is going to go into that. I think we're done. I think we are done. I think we found our answer, 13/90ths. 13/90ths, that's our fraction that would have, if we took a calculator, been 0.14 with a bar over the 4. Craziness. Okay, you are ready, Freddie, to begin your homework. Have a great rest of your day.